Hello Algebra 1, it's Ms. DeLulo here, bringing you the properties of exponents. This is the first target in Unit 4, where we will be expanding and condensing expressions with exponents, as well as learning about the properties of exponents. So, let's get started. We're going to begin by reviewing some vocabulary. A monomial is an algebraic expression with one term. Here's an example of a monomial. Now, even though this monomial has a lot of different parts, the 3, the x, the 4, this is actually only one term because all of these are combined using multiplication. A binomial is an algebraic expression with two terms. Here's an example of a binomial, 3x to the 4th plus 5y squared. This is a binomial because it has two terms that are combined by addition. Remember that terms are separated using addition and subtraction. A trinomial is an algebraic expression with three terms. Here's an example of a trinomial. 3x to the 4th plus 5y squared minus 10. This has three different parts separated by addition and subtraction. A polynomial is an algebraic expression with four or more terms. We use the general term polynomial to describe something that has four or more terms. So, we have 3x to the 4th plus 5y squared minus x minus 10. In this case, this polynomial has four terms separated by addition and subtraction. Now, even though we have lots of different pieces in all of these terms above, we have coefficients, different variables, different exponents. In all of the terms above, we cannot have negative exponents, and we also cannot have variables in the denominator. That's a very important characteristic about polynomial expressions. Here we have an example of a monomial, 5x squared. In this monomial, 5 is the coefficient because 5 is a whole number that's being multiplied by a variable. Remember that coefficients are numbers that are being multiplied by variables. The x in this case, as we know, usually we would call a variable, but when we're dealing with exponents, it has a special name which we call a base. The base is what is being raised to the exponent or power. In this case here, we have 5 times 2 x's, or x squared. We are going to practice expanding monomials, and when we expand monomials, we're going to be making them bigger. We'll then work backwards and condense monomials, where we will be making them smaller. In this table, we're going to look at the monomial, identify the coefficient, the base, and the exponent, and then expand the monomial. Our first example, we have d to the 5th power. Although we can't see it, there is a coefficient of 1 in front of this first monomial. So our coefficient will be 1, and our base is the variable or number that's being raised to the power. So our base is the letter d being raised to the exponent or power of 5. So what would this look like expanded? Well, we would have our coefficient times 5d's, 1 times d times d times d times d times d. We have 5 different copies of d. That's what our exponent tells us. In our second example, we have 8c cubed k squared. Our coefficient that's being multiplied by variables is 8. In this case, we have two different bases that are being raised to powers. Our first base is c, and our second, k. c is being raised to the 3rd power and k to the 2nd power, which means that when I expand this, I will have 3 copies of c and 2 copies of k. In this third example, our coefficient is 3, and we have 3 different bases here. Now, even though b doesn't seem like it's a base because it doesn't have an exponent in the corner, we still, as we can see, have 1 copy of b. We just don't write the 1 to represent that there is 1b there. So, our exponent for p, there are 5 of them. We have 1 copy of b and 3 copies of x. So let's expand this. We have 3 times 5 copies of P. Can't forget our 1B and 3 copies of X. And we multiply all of those together. Now I'd like you to pause the video and try the next one on your own. Then unpause the video and check back over here so you can check your answer and see how you did. Great job. Now we're going to move on to 10 cubed. So this one is tricky. Although we're used to numbers being coefficients, in this case we do not have a coefficient because the number 10 is not being multiplied by a variable. In this case, 10 is the base. We have, according to our table, 3 copies of 10. So 10 is being raised to the third power, which means that we'll have 3 10s that we are multiplying together. In this last example, our coefficient is 4, and our bases we're going to write a little bit differently. Since HP is being raised, the quantity of HP being raised to the fourth power, we're considering HP as one base that's being raised to the power of 4. So how would we write this? We have 4 times my 2 W's and then 4 copies of HP. And these are all multiplied together. There are other ways that we can write this in expanded form, and maybe you can try one on your own. In the second table, we're going to go backwards and condense our monomials. So in the first row, we have 4 times C times C times B times B times B. So in order to condense, we need to know how many copies of each base that we have. First of all, we have our coefficient of 4. We have 2 copies of C and 3 copies of B, so this becomes 4C squared B cubed. Our coefficient, like we said, is 4. We have 2 different bases, C and B, and our exponent for each of those would be 2 and 3. In the second example, we have a coefficient of 25. We have 2 Y's, 3 N's, and 2 X's. Even though those X's are not right next to each other, we still have 2 of them, so we need to make sure that this has an exponent of 2. Let's fill in the rest of our table. So we have 25 as our coefficient. We have 3 different bases, Y, N, and X. Y is being raised to the second power, N to the third, and X squared. This next example, we are going to combine our 3 times 2, our coefficients, to be 6. Since CVB are written in order together, I'm going to consider CVB as my base. So that means that I have 2 copies of CVB. In this case, we put parentheses to let ourselves know that all 3 of those variables are going to be squared. So we should have 2 of each. Our coefficient is 6. Our base is CVB because that's what's being raised to the power, and our power is 2. In the last example, we're going to condense this. We have 5 copies of 2. This is that tricky one, like from the last table, where we don't have a coefficient because we don't have a number being multiplied by a variable. In this case, 2 is considered our base being raised to the 5th power. If you had any questions along the way, make sure that you write those questions down in the side margins. There's also some questions in the side margins for you to answer along the way. So make sure that you're taking notes as you go and writing down any questions that you have. See you guys next time.